Hi guys, welcome back to my channel. So in today's video, we are going to discuss power and energy signals. First of all, we will discuss energy signals, then we will discuss power signals. After that, we will discuss the relationship between energy and power of the signal. Right. Then we will find out which type of signals come under energy signals, which type of signals come under power signals, and which type of signals are neither energy nor power signal. So let's get started. The energy of the arbitrary signal xt is given by integration of xt. This is the absolute value or the mod of xt whole square dt, right? So it is basically the integration of the square of the signal, right? Now let's discuss the power signal. The power of the arbitrary signal xt is given by 1 by 2t integration from minus t to t, then square of xt into dt, and here this t tends to infinity always, right? We can also define power as by taking here 1 upon t integration of minus t by 2 to plus t by 2 by changing the limits, right? And t approaches to infinity xt whole square dt. So this is also the way to define power. Now let's find out the relationship between energy and power of the signal. So this is a formula for power of the signal. So consider this integration term, right? This integration term, if the limits of the signal or the signal approaches to infinity, then this signal will become, the limits have changed from minus infinity to infinity, right? And this is nothing but energy signal, right? Let me show you the energy signal, right? So replace it with energy. So this is the relationship between the power and energy of the signal. Now let us consider the two cases. First case is if the energy is finite, then how much is the power of the signal, right? Let's calculate it by using this formula. Since t approaches to infinity, substitute it, we will get ex by infinity, which is 0. Because here energy is finite, so we are not changing this term since it is finite. We just have substituted the value, t tends to infinity, and it comes out to be 0, right? So when energy is finite, then the power of the signal must be 0. So this is the first case, and let's discuss the second case, which is when power is finite. So that's the formula. From here, let's calculate the formula for Ex, energy, because we want to calculate energy, right? So here power is finite, so just substitute the value of t, energy becomes infinity. So these two cases are very important, guys. Now let's consider a few examples. Let's say we are having a signal xt, which is exponential signal e raised to the power minus 2t u of t, right? So let's calculate both energy and power of the signal, and let's find out if energy is finite, then power is 0, or if power is finite, then energy should be infinity. So let's discuss this, right? So first of all, let's calculate the energy of the signal. For that, we have to calculate the square value of this signal xt, which comes out to be, for ut, I'm just taking the limits of the signal. The limits of the signal become infinity, right? 0 to infinity. So that's my signal from 0 to infinity. Now let's calculate the energy of the signal. Ex, which is simple integration of x square dt, right? So just calculate it. For the ut, I'm just taking the limits from 0 to infinity, right? So the limits have changed now and the signal becomes this. Okay. Now let's substitute the limits of the signal. It comes out 1 upon 4. I'm taking it outside. Now e raised to the minus 4 infinity minus 4 0, and it comes out to be e raised to the power minus infinity, which is 0, and e raised to the power 0, which is 1. So it comes out to be 1 by 4 joule. So here the energy is finite. That means it is energy signal. Now since the energy is finite, now power should be 0. So let's verify it. Now let's take the integration of this term first and then we will substitute this value. Okay. Just taking out this term common, right? And it will become e raised to a minus 40 minus 4 into 0, and it will come out to be okay. Now substitute t is equals to infinity. So it will be so this term 1 by infinity is 0 and 0 multiplied by all other terms is 0. So here the power of the signal comes out to be 0, right? Now let's discuss one more example. So here x of t is a. A is generally a DC signal, right? The value of a must be 1, 2, 3, 4 and so on. Any value. So it is a DC signal, right? Now let's calculate both power and energy of the signal and let's see the results. Okay. So first of all, I am calculating power of the signal. So first of all, I am integrating this term, and after that I will be substituting t is equals to infinity. Okay, so let's do it. A square will come outside since it's a constant term, right? So it will be simple integration, right? So it will be t. So let's substitute the limits. Right. It will be 2t. Now the t terms will get cancelled out and we are left only with a square. Okay. Now if we substitute t equals to infinity, then there will be no change in this term because the t terms are already cancelled out. Okay, so here I am having a finite power which is a square. So let's calculate the energy of the signal and let's see if it comes out to be infinity or not. Okay, so let's calculate it. The energy of the signal is nothing but integration of square of the signal. That's it. So it's very simple integration, I think. So it comes out to be minus infinity and finally it comes out to be infinite. So Here also it is verified that if the power of the signal is finite, then energy of the signal is infinite, right? Now let's consider one more case. So here I am having increasing exponential signal, which is e raised to the power 2t ut. Okay, so let's calculate the energy of the signal and then power of the signal. So here first of all calculate xt square, which comes out to be e raised to the power 4t, and for ut I am changing the limits from 0 to infinity. Now let's calculate energy of the signal, which is simple integration of the square of the signal, right? So here I have changed the limits for ut signal, right? Now just substitute the given values and it comes out to be e raised to the power infinity is infinity minus e raised to the power 0 is 1. So infinity minus 1 is always infinity, right? And infinity by 4 is always infinity. So here the energy of the signal is infinite. Now wait, we have noticed earlier the two cases in which when the power of the signal is finite, then the energy of the signal is infinite, right? So here I have calculated the energy of the signal, which is infinite, so the power must be finite, right? Let's check. So just first of all, let's integrate this term and then substitute infinity for t. Okay, now 1 upon my 8t, t approaches infinity, and this term e raised to 4t minus 1. Okay, now let's substitute the value of t, right? So it comes out to be e raised to 4 infinity minus 1, 8 infinity. So it is infinity by infinity form, right? So let's apply L'Hospital's rule. Okay, so let's differentiate numerator as well as denominator. We get cool. So it is, now substitute t approaches to infinity, it comes out to be infinity. So here this is the third case in which the energy of the signal is infinite as well as power of the signal is infinite. So this type of signal in which both energy of the signal and power of the signals are infinite, these kind of signals come under the category of neither energy and nor power signals, right? So let's discuss what type of signals are energy signals and what type of signals are power signals, and what type of signals are neither energy and nor power signals. Okay, before going further, let us discuss the two terms in detail. The first one is absolutely integrable and other one is unbounded. Most of the students got confused in these terms, right? So absolutely integrable means any signal whose integration should be less than infinity, right? Integration of xt dt should be less than infinity. So this means absolutely integrable. Cool. Now second one is unbounded. Unbounded signals are those signals in which at any point the value becomes infinity. Okay, that means we are having a signal and at any point the value becomes infinity. Let's take example as xt is equals to 10t, tangent signal. Now let's discuss the 6 cases or these 6 signals, and this will clarify your result. Okay, so let's plot the graph for these signals. It is negative exponential signal or decreasing exponential signal, right? So I'm just drawing roughly. So it's something like this, negative exponential, decreasing exponential. It's a DC signal, right? DC signal means the value of A is constant. Okay, Then sine signal, I think you guys are already aware of sine signal, right? Then step signal, its value starts from 0 to infinity, 1. Okay, then ramp signal, and then exponential signal, but this time it is increasing exponential. So let's discuss first neither energy nor power signals. These type of signals are unbounded signals. Okay, all the unbounded signals will fall in the category of neither energy nor power signals. So from these 6 signals, let's define neither energy nor power signals. So unbounded signal, decreasing exponential, it is bounded, right? So here we can say that this ramp signal, its value goes infinity at any point, right? And this increasing signal also, increasing exponential signal also, its value will also become infinity at any point. So these two signals are totally unbounded and categorized as neither energy nor power signals. Okay, tangent tan signal will also come in neither energy nor power signal. Now let's discuss energy signals. Energy signals are basically absolutely integrable. To calculate energy is very simple. So it's just integration of the square of the signal. So it must be absolutely integrable signal. Okay. So from these 4 signals, which type of signals are categorized in energy signals? Yes, the signal should be absolutely integrable. So here, this decreasing exponential is absolutely integrable, right? So this is categorized as energy signal. Now power signals. So the remaining signals, DC signal, sine signal or step signals are power signals. So how do we define them? So basically all the bounded periodic signals will fall under power signals. Okay, so periodic signals, but it should be bounded, fall under power signal, and all the bounded but not absolutely integrable signals fall under power signal. So the remaining these 3 signals are power signals. So that's all for the today's video. I hope these videos are helpful to you. And for more such videos, please do like, share and subscribe to my channel.